Alrighty. Now, what do we use work sets for? Page 4. Now, one of the things that you should know about work sets, if you are working on a big project, and by big I mean hundreds of thousands of square feet, I'm talking Vancouver Convention Center big, the new one down by the waterfront there, that was done in Revit, by the way. One of the things about work sets, do you folks see the opened column? So inside the work sets dialog box, I can take a work set and close it. So if I click on a work set here and I choose close, you'll see that where it says opened, it's going to switch to no. That means that that work set is not in memory. So if you have a really large project, you can take whole work sets out of your project and flush them out of memory. So on really big jobs, I know firms that when they're working on a big job, the people who are working on a project will pick the work sets that they're not working on right now, and they will close those work sets and they will be unloaded from RAM. So I think there's a rule of thumb that you take the size of the Revit file and you multiply it by 50, and that is how much RAM you should have. Maybe it's 20, I can't remember the number now off the top of my head. But if you feel like your project is kind of getting slow and you're working on a big job, take some of the work sets and you can close them, and that gets them out of memory. So that's one of the reasons there. So page 4, second paragraph there, managing visibility of whole areas of a building. This also allows you to deal with RAM issues. So managing visibility of whole areas of a building, that's true, but commonly it's used to help when RAM feels like it's you don't have enough of it. Now the most common use of work sets is for building systems. And what I mean by that is the exterior of the building versus the interior, versus finishes, versus structure. So if you want to have a 3D view where you can just look at the structure of a building and look at your slabs and look at your columns and look at your beams and look at how all the loads are being transferred downwards through a building, you can do that. So I've got a project here just so you guys can see how work sets are commonly used by architectural practices. Now, one of the things about work sets is that you can have different kinds of objects in the same work set. So you can have a floor and a column and a beam that are in the structural work set. So if you want to just see the structure of your project, so here what we've got some columns and some walls, and all of these walls are in the same work set, the structural walls. The beams are in the same work set. My floors here are also in the structure work set. So what does that mean? I could take the interior of my building and turn it off. I can take the shell of the building and turn it off. And that way I can just show the structure of my building on its own and hiding what would normally be seen, which would be the architecture of the building. So I could take all of that stuff and turn it off very quickly by hiding your exterior work set. So this allowed us to go over the structural design with our engineer and with our mechanical engineer as well, as we planned HVAC routing through the structure of the ceiling in the showroom. Well, what I've done is I've duplicated the 3D view. So here's the original 3D view. And what I simply did was I made a copy of it. And in this view, I went to my work sets and I took them all, first of all, and I hid them all. So now they're all hidden. But I just wanted to show my two structural layers, so I control selected those and forced them to be shown. So there you go. So now it's just the structure work set that's being shown. So you can see the footings and you can see the foundation walls and all the other structural aspects of this job. So that's the most common, managing work visibility of whole systems of a building. Now, one of the pitfalls of working in Revit is that you have people in your office who have not evolved. They would probably still go outside and climb trees and throw coconuts at you and do all manner of stupid things. So unfortunately, we can't get rid of these people. I'm totally talking tongue-in-cheek here. But sometimes people will do things that you wish they didn't do. And you have various levels of Revit expertise in your firm. When we first introduced our interior designers to Revit some years ago, they were accidentally deleting things because they thought, oh, that's just a line across the screen that I don't want to see in my floor finishes plan. Well, it was the entire slab for one story of the project that we were working on. And about 10 minutes later, one of the architects started freaking out, like, oh my God, where is the slab? And that turned out that one of the interior designers had accidentally deleted it. So if you're trying to lock down that sort of stuff from happening in your office, it's a little hard, but here's a little workaround that you can use, and it's listed on the bottom of page 4. Now, as you know, as I've told you, whenever you select an object and you start modifying it, Revit automatically lets the central file know that that object has been signed out by you. Now, you don't even necessarily have to edit the object. When you click on an object, you folks see that puzzle piece that's there on the screen? If I click this little puzzle piece here, that's it. It's mine. I didn't even have to move it or make any changes. So in fact, I could select the whole wing of the building, and you can see all those puzzle pieces. You don't have to go around and click every one. You can just right click and say, where is it here? Make elements editable. Don't say make work sets editable, because then everyone will want to kill you. Just choose make elements editable. So you can window select a bunch of stuff and make elements editable, and now they're all yours. Nobody else can edit those objects until you save to central. Now they're editable in my name. So now when I go to save to central, I can relinquish control all of those, and now W. Macaulay would be out of those objects. No longer would I have control. Now what we want to do is make a fake user. So what you do is you close the project down, and temporarily, just so that no unintended changes can be made, you go into your options and you create a fake name. Now, here I'm having to sign out of Autodesk to do this, so I'm going to make a fake name. I love all the fake names. I've got the best fake name. Donald Trump. So Donald Trump is going to sign into the project here, and so what we would do now is we would go and open our central file, and it's going to make a new local file, and instead of saying W. Macaulay at the top, it'll say Donald Trump. Now in the notes it suggests that you make the name locked. So let's say here that I don't want anybody moving the grids around. So I select one of my grids. You guys know about the keyboard shortcut for isolating a category? IC, isolate category. So there we go, just all of my grids. And I can window select them all, right click and choose make elements editable. So now, user Donald Trump has access to these grids alone. And so what I'm going to do now is is exit the project. So I'm going to go up to File and choose Close. Now Revit's saying, want to make some changes? Sure. Have a look at this. You have ownership of elements that you didn't modify. What do you want to do? Do I want to relinquish? No. You want to keep these objects signed out so that nobody else can make changes to them. So I'm going to keep ownership even though I'm quitting. So that's it. The fake username, I need to get rid of that. So I go back to my file menu here and go to Options. So get rid of the fake username and put in your actual username from, so here I'll just sign back into Autodesk. Okay, so now I can go back and open up my regular local file, and you folks will see straight away I will not be able to modify these objects. So there's that grid. Take this grid, try and change it. Can't edit the element until Donald Trump saves to central. So in this case you'd put locked in here. And so those objects now would not be available for people to change. So that's the idea. They're using these ghost users so that you can prevent unwanted changes. It's kind of an ugly workaround, but as far as I know, that's the main thing to do. Over on page 5, just a few bit of notes there about what you should do when you're working with work sets. Just a little note there about working as a sole practitioner. So even if you are not in an office environment working with multiple users, work sets are really good once your file gets to be a certain size, and it's around the 100 meg range. And the reason is, you guys know when you save a file and it makes .001, .002, .003? Right. Okay, so in that case, if you have a 100 meg house that you're working on right now, each time you hit save, without work sets, Revit saves that whole 100 megs to your hard drive, and you've got these 100 meg backup copies. Once you've enabled work sets, each time you hit save, Revit only writes the parts that have changed. So when you use work sets, your saves go faster, Revit uses memory better, and your backup copies of your project take up way less space. So if I've got a 100 meg house that I'm working on, and I'm working with work sets, instead of having 500 megs, you know, my original plus 4 full copies, I might only have 175 or 200 megs of data on my hard drive once I'm using work sets. I'm not going to go over the other stuff here with working out of the office. You guys can just read that and make a note of it. I am going to move on to work set backups. Now, as soon as you have enabled work sets on your project, Revit makes a backup folder wherever your central file has been stored. So here I've got my central file. And underneath your central and your local file, Revit creates a backup directory. So each time you hit save, Revit makes a small write to part of your file, whether it's your local or central file. And in the background, Revit has this backup folder which is filled with a bunch of very scary looking files. Now, a lot of this stuff has to do with what's called an incremental save methodology. It's related to like when you do backups of your server onto a tape or onto a backup hard drive for record keeping. But in any event, I told you that Revit only saves the bits that have changed. So you've got your local or central file, and then you've got the backup folder underneath. So in this backup folder is where you can go back to, you know, however many saves back, and you can roll the project back to a earlier point in time. So on the Collaborate tab, if you choose the Restore Backup, what you do is you go and find your central or your local file, and then find the backup directory that's there in the same folder as your central or local file, and open it. Now what Revit will show you is all of the prior saves that have been made and what time they happened and who it was who did the save. So if there's other people working in your office at the same time as you, you would see all of their names listed there. So if there was a particular point in the morning where some changes that were made that you don't want them, you can click on that earlier time and you can either save that file back out so you can have a look at it, or if you're sure that's the one, that's the time where you want to go back to, hit rollback, and it takes the project and rewrites the central file back to that point in time. So it's like Time Machine on the Mac. You can go back to an earlier version of the file. So that's what's just being explained on page 6. On page 7, just some maintenance issues, some suggestions there so that things will go more smoothly for you. On bottom of page 7, if you're working in an office that's doing a joint venture with another office in another city or in the same city, usually your central file is located within the same office. So on your server, you've got your project central file. But if you're working with another office in another location and you need to collaborate over the internet and you don't want to pay billions of dollars to Autodesk per month for your users to use Autodesk's cloud, then you can use what's called Revit Server. And what Revit Server is, it runs on your server. So Revit Server is a program that your IT guys would run on your server. And what you do is, in Revit Server, in your Office's server, you say, hey, these are the IP addresses of the other computers on the internet, the servers in the other locales that Revit Server should talk to. So if you have your office, Office A, working somewhere else, you can have Office B, anywhere on the internet, and as long as there is a connection between them, what Revit Server does is it synchronizes between central files. And keeps them up to date between offices over the internet. So if I make a request to edit an object here, it's not quite as fast as updating your local central file, the object that I signed out. But as soon as I sign out an object, a few milliseconds later, other offices will be in the same boat. And so that user in the other office will not be able to edit that object anymore. So each time somebody does a save to central to their server's central file, Revit servers on your office servers, they'll start talking to each other and updating each other across the internet. So it definitely takes some IT skills to get that set up and working, because you need to make sure that your servers are able to talk to each other over the internet and to open up some ports and all that good geekery stuff. So that's another option if you're doing a joint venture, or if you have multiple offices that want to work together on the same project simultaneously with Revit. So that is page 7. Page 8, I think you can just read about that. I don't think we need to talk about that too much more. What we're going to talk about now is linking Revit models. Now, what you guys need to do now, I'm going to close this file down. Now, go into the Session 10 folder for tonight, and you're going to find these 3 files, Arch, MEP, and Structure. And we're going to work with those. And we're going to talk again about shared coordinates. So earlier we talked about shared coordinates as a way to set up the geodetic elevation of your site and to get your site, your building rather, to point to true north. So those are the 2 goals of shared coordinates that we've been talking about. And so a third one is to get all of your consultants so that their projects are geolocated properly with respect to each other. So that means that we want our architecture and our HVAC and electrical and our structural engineers to all have a shared origin, so that all their models, when we link them together, they end up in the same place in X, Y, and Z. So that's what we're going to look at right now. Now, I'm going to open up the architectural model. I just ignored that warning that came up. Okay, how many architects, when they get started in designing a project, are paying attention to where the project base point or the survey point are? How many architects pay attention to that? None. Who cares? Just design. Get that sucker drawn. Doesn't matter. And it turns out it doesn't really matter anyway. Now, once it becomes time to agree on a point of reference for all of your consultants on the project, the easiest thing to do is to take your survey point and move it to a point of reference that the whole team can use. So you turn on the survey point, move it to a property line corner, move it to a grid line intersection. It doesn't matter. Just use a point of reference that can be agreed upon by the whole team. Now, once the architect has set that up, and really it's kind of the architect's job, the engineers won't care, they'll just follow whatever place the architect decides to use. So here it's a grid line intersection. Now the engineers may or may not have gotten the Revit model from the architect so that they can start design. They probably have, but maybe they haven't. And even if they did, they might have linked the architectural model in and put it God knows where, right? So at this point, there's no telling if our engineers have a point of reference or if they're using this grid line intersection as their point of reference. So now what we need to do is say, Mr. Structural Engineer, this is going to be our point of reference. Please get your model set up accordingly. So let's see how that would work. So I'm going to close the architectural model now. And so now I'm pretending I'm the structural engineer that is opening up okay, what did I do? Where did I put it? Okay, here we go. So I'm the structural engineer now, and I'm just opening up my project. And what I'm going to do is I am going to link in the architect's model to help me get sorted, to get myself coordinated with where the architect has their model. So what we're going to do here is well, we're doing the exercise. Oh, no, we're not. No, that's later. Okay. So you set your structural engineer, you tell them, link in our model. So the structural engineer would go to Insert and link Revit, and they would link in. So just go into your Session 10 folder and grab it. So here, the structural engineer is linking in the architectural model. Now, what one more setting should I choose here? Anybody? It's kind of hard to read because it's so small. That's right, shared coordinates. That's what we want. We want to choose auto by shared coordinates. Now, coordinates have not yet been shared between these 2 files, so when we open it up, Revit says this. So what's happening is when the structural engineer links in the architectural model, it just kind of fires it down wherever. Right? So there you can see there's the linked architectural model. So what you need to tell your engineer to do is line up the architectural model on top of yours. So we use the move command, and I will use the grid line intersection here. And yeah, I better make sure I use the snap intersection tool. Snap intersection SI. So there we go. I'm snapping from the intersection of those two grid lines, and I'm going to move it to my grid line intersection right here. There we go. So now the architectural model and the structural model are totally hooked up in plan. It's all linked up perfectly. What else should we check? We've got them linked up in X and Y. We should also check elevation. So I just go to any one of my elevation views here, and I just check to make sure that my levels from the architect's model are lining up with my levels here in my structural project, and they do, so at least that much is good to go. Now, have a look at where the engineer's survey point is. It's right with this project base point. Now what we need to do is for the structural engineer's survey point to get moved to this grid line intersection, which is our common point of reference for this project. So what the engineer needs to do is select the architect's model, and you'll see the bounding box around it here. Now remember when we linked our house into the site, that we published coordinates. So that is the site determined the location of the survey point for our house. Now in this case, instead of publishing coordinates here, the engineer is going to acquire shared coordinates from the architect. So the architect has decided where shared coordinates are going to be. So the structural engineer moves the architect's model into place, then hits the shared site button when he's selecting the architect's model. So instead of publish, like we've done before, we're going to acquire. So this means that the structural engineer is getting shared coordinates from the architect. And then hit reconcile. And lo and behold, the survey point moves for our structural engineer. So the structural engineer is now on the same page, coordinate-wise, with the architects. This also means now that from any time now, if the structural engineer gets a new copy of the architect's project, it will for sure always come in at the proper location. So that is one of the main goals of shared coordinates, is to help get our geometry into the same location in 3D space. So that is page 9 and 10. Now we're moving on to page 11. Think of two of your design disciplines on a project. So you've got all your different consultants. Which of your two consultants tend to lock horns the most when it comes to eating up space in your building? Yes. Mechanical and structural. Every freaking time. So what happens is structural's got a big beam, and you can sure as hell bet that mechanical engineers are going to want to put a duct right through it. So, and you can see it even here, we're getting close. All these building systems take space. If you guys remember that auto dealership I was showing you earlier, that was the problem there too. We had to snake in a big duct for ventilation in between a whole bunch of different beams. So it's a big problem. Now, With Revit, if your structural engineers and your mechanical engineers are both using Revit, you can do interference checking between those two consultants if they're using Revit, and it works pretty great. So what I'm going to do here is I'm going to save here. Now unfortunately, Revit will not allow you to do interference checking between two linked models. So if you're the architect and you've linked in the mechanical model and you've linked in the structural model, you can't do interference checking between those two linked files. So what you got to do is you got to call up your consultants and say, hey, send me your Revit files, and then open up your structural engineer's file, link in your mechanical engineer's file. So let's do that. We've got the structural model open. Now what we're going to do is link in the mechanical engineer's file. So now we're pretending we're the architect again, who we've got the structural engineer's file open, and we're going to link in the mechanical engineer's work. Now if I go to 3D, you can see both files are here. Now what I'd like to do for now is I'm going to unload the architectural model so we can do the interference checking. So what I'm going to do is I'm going to go to Manage and then Manage Links. I think it's also on the Insert tab. So go to Insert and then Manage Links, and what we're going to do is take our Revit architectural model and we're just going to unload it for now. So select the row for architectural model here and unload it. So this is the Insert tab, Manage Links, go to Revit, find the architectural model and unload it so we won't see it anymore. So now it's just our structural model. So now what we're going to do, I'm going to go back to the...
For me, it doesn't show architectural model.
Have you got the structural model open?
It shows close up the combination of close up and short. It doesn't show...
Okay, so what I've been doing here this whole time, folks, is I have the structural model open and I linked in the architectural model. So if you didn't follow that process, come back later and look at the process on YouTube and you can repeat it again. So that would be the structural engineer getting shared coordinates from the architect. So now I still have the structural engineer's file open, but in Manage Links now I've just hidden the architectural model. I've unloaded it for the time being. Now what I'm going to do is I'm going to link in the MEP model, again by shared coordinates. And link Revit. So here's, I think this one's out of whack. Yeah, so here's my, you guys can see here, the mechanical model is out of whack. I think what I'll do is I'm going to hold off on the linking of the mechanical into structural. So what I'm going to do, folks, I'm going to close. So I'm going to close the structural model. And let's go through the process of getting the mechanical engineer sorted. So now we're pretending we're the mechanical engineer. I'm going to go to the Open dialog box here, open up the MEP model. So here's our MEP model. We've just got an air handling system shown here. So ladies and gentlemen, open up the MEP model 2018. And we're going to go into the floor plan for this as well. So you can see under my HVAC floor plans, I've opened up floor plan 1, mechanical, and you can see our grid lines are here. So again, this is us pretending to be the mechanical engineer who's being instructed now to import the architect's model, get it into place, and acquire coordinates from the architect so their shared coordinates icon can be in the right place. So right now that symbol isn't even turned on. The project base point and the survey point are stored in the site folder. So if you go to site and you turn on the survey point. There it is.
Just a survey point?
Yeah, just a survey point. That's all we need. Just so we can observe the change in location of the survey point after we've acquired coordinates from the architect's model. So now the mechanical engineer would be instructed to insert and link the architectural model. So go ahead to insert and link Revit and bring in the arch model again by shared coordinates. And of course Revit will tell you again that these models do not share coordinates. That's fine. All right. So yeah, they're out of whack. So the grids here aren't quite lined up, so let's see what's going on here. So this grid line intersection here has to be moved to this one. So I'm going to move the architectural model into place. I'm going to zoom in here to make sure I got the grid line intersection, and then move it to my mechanical grid line intersection. So now my architect's grid lines are lining up with my mechanical grid lines. So in plan, we're good. Just need to go into an elevation now. Looks like we're good there as well. So now we need to acquire coordinates from the architect's model. So select the architect's model. You'll see the bounding box letting you know you've got it selected. So now the mechanical engineer is going to go to shared site, and they're going to acquire coordinates from the architect. So our mechanical engineer is getting the survey point location from the architect's model. So we hit reconcile here, and you will see that the survey point moves to a new location. So that's the grid line intersection, just as the architect set up in their file. So now, the architect, mechanical engineer, and the structural engineer are all sharing the same point of reference. So now when we hit save, we're good to go. So what would happen now is that the structural engineer and the mechanical engineer would continue their designs, and they would send their Revit projects to the architect for coordination, or maybe they do it themselves. So regardless, what we're going to do now is I'm going to close out of the file here. So now what I'm going to do is I'm going to open up my structural engineer's file again. Oh, did I not click that? I'll be waiting here all night. Okay, so I'm just ignoring this error dialog here. Now in plan. So here's my structural engineer's Revit project. I'm going to import my mechanical engineer's HVAC design. Insert. Link Revit. And I'm going to bring in the mechanical engineer's model by shared coordinates, and it's going to land right exactly in the proper location. I'm going to ignore this one as well. So our grids are in the right place, and in elevation our levels are in the right place. So this is what you are going to see. If you're not seeing this when you go into 3D in your structural engineer's model, just wave at me and we will get you set up. This is where we're headed. So here we can see visually our two building systems, our structural building systems and our mechanical building systems together in the same file.
And can we
Well, to do this kind of work, it's not going to help us, right? So what really, as one of the students noted here, is that it's always structural and mechanical who get into conflict. So I don't need to open up the architectural model. I'm just going to open up the structural model, link in the HVAC, the vents, the ducts, and see if there's any conflict. Anybody need a hand here getting this set up? Now, just visually, if you look at what's going on here, we can visually already see that there are some conflicts. You can see this duct here, this flexible duct. It's actually cutting through a couple of beams here. And there's a few other things here that aren't going to work. So we've got some other conflicts. Now, you might be able to see them visually, but Revit will actually report back to you where those conflicts are. So on the Collaborate tab, interference check. So here you run an interference check. So if you want, you can look at categories, 2 different categories in the same project, or you can run interference check between objects in the current file and one linked file. So this is the limitation. I can get Revit to check for conflicts between geometry in the currently open file and one other linked file. If I had 2 linked files in here, I could only show one of them in one category, in one column here. So if I've got a linked file in this column or in this column, the only option Revit will show me in the other is current project. So if I have current project and project A and project B linked up, I can't put project A in one column and project B in the other. As soon as I put project A in one column, the other column will only show current project. If I put project B in one column, then it'll still only give me the option of current project in the other. So the only way Revit will do interference checking is between geometry in a currently open file and one linked file. So that's a limitation. Because Autodesk wants you to get Navisworks. Navisworks is Autodesk's 800-pound gorilla for detecting clashes between different consultants' geometry. It does it very quickly, but I could write a whole course on Navisworks, or at least half a course on Navisworks, so we're not going to go there. We're just going to show how you can do it within Revit. So all of these categories here, inside the current project, all the structure, all the floors, all the walls, we select it all, and then hit a checkbox here so they'd all be checked at once. Came over to this side, same thing. Hit all, and then hit a checkbox to make sure they're all checked at once. So all the geometry in the currently open file is being checked to see if it occupies the same space as geometry in our link file. And we hit OK. And Revit will now show us the list of conflicts. So we've got a conflict here, and Revit, if you hit show, where is it here? Oh, there it is. So it's showing that there's a conflict, oh yeah, between that air handling unit and the exterior wall. Now it's showing that there's conflicts between that duct and that beam. So here you can click the duct or click the beam, and it'll show you where those conflicts are occurring. So visually you can see straight away where that's happening. Now if you have an absolute boatload of geometry in the view and you just can't see it because there's too much stuff in the way, before you run the interference check, you can go to wireframe so you can kind of see through everything. It might be a bit of a mess, but whatever. So now at least you'll be able to see, just because they'll turn orange, it'll show you where these conflicts are occurring.
If you have a common and Revit for itself open their category, or we need to open each of them?
You'd have to open it. So here I have to open these categories so I can see which two objects are in conflict. So once you're done, you can export the report to an HTML file. And your exercise tonight on page 11 is going through this exact process and exporting the report as an HTML file. So once that's done, save your HTML file to your desktop and copy it into your sharing folder on the iDrive. So I give you folks about 10 minutes to go through the exercise on page 11, and then we will carry on.